So welcome to this course Machine Learning for All. Now we are in the topic module 3 and topic 4. So here we will be understanding basics of your two algorithms. For let's say for clustering we will be understanding the basics of k-means algorithm, and for association rule mining we will be understanding frequency based association, or that method formerly known as a priori method. Okay, so first let us jump to the KNN algorithm, or k-means algorithm rather than. Sorry. So in case of k-means algorithm, so what is the concept is that it tries to group all the nearest actually members or nearest observation. So let's say if you have in a graph, or let's say if I plot all the observation, let's say which has two dimension or two features, maybe I'm just considering age and weight, two variables, and I have couple of observation like this on the scatter plot. Now here without using or emphasizing mostly on age and weight, by just considering the similarity between this all these points, we can group into different groups. Now already this is we are implementing a k-means algorithm. Now the problem with the k-means algorithm is that you have to mention the how many clusters he wants to generate out of the data, or how many groups he wants to generate out of data. So in that case the algorithm is nothing but the first you define the centroid. So first let's say if we wants to generate two clusters, the step one will be generate or define two clusters by selecting two random observation. So what is the meaning of that? Let's say from this data itself, I'm just changing the color. Let's say I'm just, if I make it red, okay. So in that case, let's say randomly, if I just consider this is one centroid and this is one centroid, then step 2, calculate distance of all the points from the clusters, or from the centroid base. Centroid. So what is the meaning of that? So let's say once I define the two centroid, now I have to just find out the distance. So now distance between these 2 points, then distance between this point, this point, this point, this point, this point, or this, also this, another same for this also. Let's say I want to just find out the distance from this. So once I know the distance, then I can easily identify who are the nearest to that particular centroid. Once I identify them, then what we have to do, we have to just cluster them, and maybe after clustering you can get a new set of clusters. Let's say if I just remove this, so there maybe after calculating all the distance, my new clusters are like this. One cluster here and another cluster here. So once you create your initial cluster, then you have to recalculate the centroid by taking the average of all the observation within that particular clusters. So maybe that calculated observation is not on the specific point, maybe here. So that is a new location of your centroid, and here also maybe the centroid is over here. Now again you have to repeat the same approach. You have to calculate the distance from all the points from this newly constructed centroid, and slowly steadily with the iteration this centroid will shift itself, and finally it will rest to a particular suitable place, and that will be the final cluster center. And also the member will be fixed as per that. So my step 3 reallocate the members for each iteration based on distance from centroid and recalculate the centroid by calculating the mean of members in a specific cluster. Okay, and slowly steadily with maybe 5 steps or 4 steps, this will be stabilized and your cluster centroid will not change its position. Then you will understand that okay, the clustering is now stabilized and you have reached or you have converged to the final result. Now how should we calculate the efficiency of our clustering? So basically, what are the metrics that are available with us to measure the efficiency or the quality of the cluster? So now 2 measures are there. One is Shillard score, another is sum of square within. So a simple concept is the sum of square concept. So SSVW. So that is nothing but the within the cluster. Let's say this is a cluster. You have a centroid over here. These are the points. So you just take the distance from this and calculate the sum of square. So that is the measure of sum of square within. Now what is sum of square between? So let's say you have another nearest cluster. So there also the members are available. So now what you will try to find out? You will just try to find out what is the average distance or average sum of square from another cluster centroid of that particular members. So that indicates the sum of square between. So basically if you just the basic formula is if you can calculate the sum of square total by calculating the total observation means, then it is very easy that SST minus SSW will be SSB. So within cluster you calculate, for all the observation you calculate the sum of square total, and then you can easily find out your sum of square between. So the desired thing, the sum of square between should be increased. So higher sum of square between is desired and lower sum of square within is desired. Based on these 2 metrics, you can easily understand that how well you have clustered all the points. So you have to just check these 2 values simultaneously for multiple options. Let's say if you have created 2 clusters, 3 clusters, then you can compare the performance of the clustering based on these 2 values simultaneously. Another is the Shillard score. So Shillard score is nothing but you can calculate A by AI by BI. So this is for the individual point. Let's say AI is nothing but the average distance from the, so this is nothing but the average distance between your single point and your centroid, and the b is nothing but the distance between your individual point to the nearest cluster centroid. So another thing is that the same formula can be represented with this, that you calculate bi minus ai divided by max ai comma bi. So again, in this case, when you are considering as a whole a cluster, then this bi is nothing but the average distance from the nearest cluster, and for all the points, let us say all the points, how much distance it has from the another nearest cluster centroid, and ai is that what is the average distance between all the points and its own centroid. And then you can just take a ratio of bi minus ai divided by max ai minus bi. So now just if you just check this values, so then ai should be lower value, bi should be higher value. So in that case, when you are evaluating an individual point in the sense of that Shillart score, so it is nothing but it should be higher value is desired, because if it is a higher value, it is lower value, then definitely overall term will be decreasing, and 1 minus some decreasing value, it should increase. So Shillart score for individual, this is individual point in a cluster, and this is for overall cluster you can calculate. Okay, here also you should have a higher value, because I wants that all the points should be apart from the nearest clusters and nearest to its own cluster. So, so these are the two metrics that will be very useful to actually measure the efficiency or quality of your clustering. So, hope you understood this concept of clustering, k-means clustering, and the how this clusters can be evaluated, or the quality of the clustering can be evaluated with the help of two things: SSW, sum square within, sum square between SSB, and SS or Shillart score. So next we will be moving to our next topic, that is your association rule mining. Association rule mining. Try to understand a particular algorithm known as the a priori algorithm. So a priori, this actually calculate the association based on the frequency. Let's say I have couple of entries. Let's say in a data set, milk, banana, egg. Another, maybe I have observation, milk, egg, milk, then maybe tea, another option, milk, sugar, egg. So if you have this kind of entry, let's say this is the data point 1, 2, 3, 4, so 4 observation, then based on the frequency itself, we can easily calculate the association rule between the different frequently appearing items. Let's say according to this data, if we just check, let's say milk and banana, this thing appears only once. So I can easily calculate the support, which is nothing but again a measurement of that how well a particular relationship association is, that is nothing but support equal to 1 by or you can barely calculate in the terms of frequency, that is 1, but in this case it is appear once out of 1, 2, 3, 4 cases. So 1 by 4 it is the support for that particular case. Now if you just consider another relationship, that let's say I have milk and egg, how many times it is appearing. So here also 1 times, milk banana, milk egg 1 time, milk tea 1 time, milk sugar 1 time. Let's say another time, if I just if the same milk egg and sugar appear in the entire data set, then I can easily calculate my confidence of this particular event. Let us say, so basically what I am trying to understand, so based on three metrics we can easily identify my top association. So in that case you have another thing is confidence and lift. So again it is desirable the higher value of support, higher value of confidence, and definitely higher value of lift. So generally lift is it may value can appear in your analysis, you can say 0 or more than 1, more than 1. So more than 1 is better, and support and this confidence can be go higher. They generally in the fraction value 0 to 1, and this only lift can be more than 1 value. So now what is the confidence formula? The confidence can be calculated easily with the help of your, let us say I am just writing a easy formula for this, so it will be very much easy and generalizing. Support is frequency of observation divided by total observation. So this is a specific. So let us say here specific observation may be milk banana or milk egg, this kind of a sequence, or this may be pair of events, and here confidence is nothing but support of x and y, or two items appearing in a data set divided by support, individual support of x. So one example we will do and understand what is that. Lift is nothing but again support x comma y divided by support x into support y. So one simple example that can be done with the help of confidence here itself calculation. Let us say we want to calculate milk and egg. For this we want to calculate the confidence. So then we have to just find out the support for how many times they appeared together. So 1, 2, twice they appeared. So and how many times total observation, see 1, 2, 3, 4, 5. So 2 by 5 is support for support milk and egg. That is 2 by 5, and only support for x in the sense that the support for milk, how many times it appears? 1, 2, 3, 4, 5, 5 divided by 5. So support of milk 5 divided by 5. So confidence for milk egg pair is 2 by 5 divided by 5 by 5. So that is nothing but 2 by 5, 0.4. And I can similarly calculate the support or lift for the same thing. So lift will be equal to lift of your milk and egg, lift of this equal to, let us say we have already calculated our support for milk and egg, that is 2 by 5, and divided by how many times support of x, that is 5 by 5, into support of y, that is egg, how many times egg is appearing? 1, 2, 3, 4 times. So out of 5, so 4 divided by 5. So if I just calculate 2 by 5 divided by 4 by 5, that is nothing but 2 by 4, 0.5. So after calculating this kind of matrix for all the relationship, let's say milk bread, milk egg, milk tea, milk sugar, milk egg or egg sugar, again sugar egg sugar, or banana egg. So you have to calculate the support, confidence and left, and based on the higher value you can select top 10 rules or top 5 rules out of the data. So basically this was the basic concept of a priori based or frequency based association in the data. So now this is kind of a observation based data. Definitely you have observed this is not related to any continuous type of data. Basically some level data, on level data you have to just apply and you have to just find out the association. So how this association can be useful for you? Now association can be very useful for you when you have to just identify frequent appearing item chains. Very much useful in case of, let's say, retail analytics applications, or maybe when you are planning for inventory planning, or maybe you are trying to find out some event, analyze some event. So how the events are related to each other based on the frequency, you can find out, okay, top 10 rules, and you can comment or make a kind of generalized comment out of it. So hope you have understood these two concept of k-means and association rule mining based on a priori or frequency. We will be implementing this thing in the Excel, and you will be solving some real life problem. In the next topic, we will be implementing these two algorithms in the Python platform. Thank you for watching this video.